Good morning. Today we are discussing about the magnetostatics. That is how we can calculate magnetic field between the current carrying wires, how we can calculate the force between current carrying wires, and so on. If we consider a charge having charge q with velocity v moving in a magnetic field b, then the force experienced by this charge Fm equal to q into v cross b. This Fm is the Lorentz force. If electric field is present in this place, then F equal to q into E plus v cross b. This expression gives you the total expression of Lorentz force, that is when both electric field and magnetic field are present. Okay, now we want to find out the dimension of the magnetic field B. If we consider the first equation, that is Fm equal to q into v cross b, this gives you the Fm equal to q vb sin theta. If we consider the velocity and magnetic field are perpendicular to each other, that is theta equal to pi by 2, then we can write maximum force equal to qvb. From this relation, easily you can find out what is the dimension of B. The dimension of B equal to force by q into v. All of you know the dimension of force ml t to the minus 2 and velocity L t to the minus 1. Whereas q, we can find the dimension of q in this way, that is current is nothing but the flow of charge, that is I equal to dq dt. I can be expressed as a dq dt, t means time, so we can q equal to nothing but at. We put the individual dimension of the character of all this in this expression, and finally we get b equal to mt to the power minus 2 a to the power minus 1. That is, if we put dimension of f, q and v, then we can, there is a L, there is a L, this will be cancelled out. There is a t to the power minus 2, there is a t to the power minus 1 and t, these both are nullify each other, and there is a a. When you put this in final expression, a will be in upwards in minus and mt to the power minus 2. Finally we got mt to the power minus 2 a to the power minus 1. This is the dimension of magnetic field, and obviously the unit of magnetic field, SI unit of magnetic field is Tesla, and CGS unit of magnetic field is Gauss, and the conversion 1 Tesla equal to 10 to the power 4 Gauss. This SI unit of magnetic field is Tesla and CGS. Now we want to discuss about some properties of Lorentz force. First one, Lorentz force does not do any work. That is, Lorentz force is a workless force. Why? The work done due to Lorentz force, if we move a charge q from one place to another place having displacement dr, then work done equal to W equal to F dot dr. And from the normal classical mechanics, we know velocity v equal to dr dt, and that's why dr equal to nothing but v dt. We put here f dot v dt, and the expression of f equal to q into v cross b dot v dt, this one, and this gives you the 0. Why 0? As f is always perpendicular to v. That's why Lorentz force is a workless force. Next solution is Lorentz force is velocity dependent. And another interesting property of Lorentz force is this force Fm, the Lorentz force, is found to be true even for particles moving at speed of light. The Lorentz force is found to be true even the charged particle moving with the velocity of light. That is, like mass, charge is relativistically invariant. Presently, you probably don't know what is relativity, Einstein special theory of relativity. You will learn in next semester. This is the most fascinating topic in physics. Next, we discuss force on a current carrying conductor. Let us consider a portion of a current carrying conductor having cross section area alpha. If we choose a small elementary section of this conductor of length dl, this portion is length dl, total length of this conductor is small l. Now we want to find out what will be the force experienced by this current carrying conductor due to the flow of charges. If we consider this a small cross section, a small section of length dl, cross section alpha, there are huge number of charge carrier here. If we consider single charge carrier, then a single charge carrier experience the force Lorentz force. All of you know Q equal to V cross B. What is the V is the velocity of the charge carrier and B is the magnetic field. And for the small cross sectional element of length dl, the charge carrier within this element is n q n alpha dl. What is q? Q is the charge of each charge carrier, n is the number density of charge, alpha is the cross sectional area, and dl is the length element. Now force experienced by this number of charge carrier is say df equal to this number of charge carrier into v cross v. In this expression q, n, alpha, all of this constant, we can represent this as I dl cross b. What is I? I is nothing but the n q alpha v, that is the current produced by the charge carrier within the considering elementary length dl. Okay, this is the expression 3. If you want to find out total force by the whole conductor, then F will be integral over the df, this one, that is integration over I dl cross b, this one. I is constant, we can make it out, this one. B is also constant, this dl carried over for only the length, and this will be I l cross b, that is force equal to I l cross b. If we consider the maximum force, then F max equal to B I L. Thus, 5/2 equal to 1. That is, when you consider maximum force, then the angle between DL and B is pi/2. That is I dl b sin theta. That's why I dl b sin 90, which is equal to I dl b or BIL. That's why maximum force is nothing but BIL. If you consider closed loop, if the wire is bent in the form of closed loop, then the force F equal to closed integral I dl cross b, and closed integral of dl means this closed integral, that is the total displacement is 0. That's why this will be 0. For a closed loop, closed integral dl equal to 0. That is, we can say that closed loop does not experience any force.